Okay, so two sum. So this is like the classic first problem everyone starts with. But honestly, the answers is not the point. What I actually want to show you is how you get to the answer, the way you think through it, because that same thinking works on basically any problem. So just let's just jump in. So here's the problem. So you have got an array, you have got a target, I'm calling it x, and you just need two numbers that add up to x, and you have to return their indices. So let's say for this 15, you have like 12 and 3. So its indices 0 and 1. So basically, one more thing that you have to keep in the back of your head is whether you need a pair exist in your answer or the actual indices, because that will that will later came like how our approach would be. So next thing. So all right. So how would you actually do this in your head? So you would just pick a number, right? Say let's say 12, and you go, okay, so I need a 3 to hit 15 now. So and then you go hunting for the 3, like, and you find it easy. But notice what you just did, like to find that next next number, like 3, next partner, you have to scan the whole array, and you would do that scan for every number. Yeah, that's the part that's gonna hurt. So if you just write out exactly that, the approach that we have discussed, it's a brute force. So every number checked against every other number. That is a two loop. So it's a n square time and a constant space because we are not storing anything. And look, it works, nothing wrong with it. But it kind of falls apart if array becomes very big because we have a quadratic complexity. So how to approach any problem and get the optimal approach basically. So this slide I actually care about is like, here's the thing about your brain, it always hands you the brute force first. So what do you think basically is the brute force? Because generally every time your brain doesn't want to store anything, so it just redoes the work over and over, which is honestly great news because it means you can always get a solution right away. You don't need to freeze up, and then once you will get the brute force, you can make it faster. You just ask yourself one question, what am I doing over and over, and you store that. That's the whole move. Brute force, find what are you repeating, what are you doing multiple times, store it, and then you get the optimal approach. So that's the pattern for like everything. So let's actually do it now. So here, what's the repeat here? So it's this, like we keep going is x minus a in the array, like over and over. And every time we scan to check, that scan is O of n. So what if we just remembered what we have already seen? Throw it in a hash set or a map, and now that check is instant. O of 1. And that's it. That's the optimization. Just that one swap. So approach 1 is one pass hash map. So here's the clean version. So you go through, and for each number you go, is my complement already in the map? If yeah, great, return both indices. If not, you just drop it in and keep going. That is off and time and off and space. This is the one that you can remember. This is the default. Then there is another approach that is two pass. That is same idea, just split into two if that's easier to picture. Build the whole map first, then go back through and look up each complement. Exact same cost. Only thing to watch, don't accidentally match a number with itself. That's all that little j not equal to I check is doing. So approach 3, sort plus two pointers. Okay, so this one's a different flavor. You can sort it first, then two pointers, one at each end. Add them up, then two small, then increase the index of the left one from one. Otherwise, pull the right one in. It's an n log n because of the sort, but the space is basically nothing. So you would reach for this when memory is tight, or you know if it's already sorted. Approach 4. And then remember I said keep this in back of your head. If you only need a yes or no, like does any pair even exist? You don't need indices at all. Just use a set. So yeah, need positions, use a map, just need true or false, sets enough. Then we can do comparison. So all of them side by side. Brute force for tiny stuff. One pass map most of the time. Two pointer when space is the thing you care about. Set when you just need yes or no. There's no single best. It generally depends on what you're working with. And honestly, that's exactly what interviews are watching for. That can you pick the right one and can you explain it why? Then the real lesson is the actual takeaway is brute force stores nothing and it pays for that and time. The second you store the repeated stuff, or you are trading a tiny bit of space for a ton of speed, and that's literally what a data structure is. It's just a way to stash data so you can grab it fast later. And that one move storing, that's the thing that turns brute force into optimal every single time. So that's the end. Now, just recapping what we have learned here. So there's things to walk away with. One, always just start with brute force. You will always get there, so you never freeze. Then second is find the thing you are repeating and store it. Third, pick your final approach based on your constraint. Brute force, find the repeat, store it, optimal. That's the whole game. If this helped it, then fine. Thanks.